Good. Okay, so this talk is about agile threat modeling with open source tools, hopefully letting become threat modeling part of DevSecOps. Let's see. So I was already introduced, so I'll skip that slide and jump right in. So you can ask yourself, that's not meant to be a poll, but you can ask yourself the question of whether you are doing threat modeling in your projects or not. And eventually not all projects you think of might be doing it in a way that would be sufficient, at least when it comes to frequent releases or even agile sprints. So if a project is conducting threat modeling workshops, which is good, most of the times this is in the beginning, in the initial phase of the project, and not being repeated or incrementally updated during the follow-up releases and sprints. So that was something I tried to tackle. And how did we tackle the testing problem in terms of security tests, for example, in DevOps? By just automating things as best as possible. So some people call it DevSecOps, but it could also be just called DevOps, so that security should be obvious in that. And that has succeeded due to some kind of automation magic. So all of these tests we nowadays use in pipelines are more or less automated, scanning code, scanning dependencies and things. So the idea was to tackle the same thing, this problem of integrating threat modeling into DevSecOps in the same style, by automating things as best as possible and let eventually threat models also be something like code. What are the benefits of code? It's editable in any IDE, even VI if you want. Checked into the source tree. So that's basically living along with the project if you want to check that into that project's folder. You can div it, revert it. It's branchable, mergeable, just as, well, code, which it actually would be. And therefore it's collaboration capable and testable, verifiable, reproducible in terms of what it creates as a result. So these are some major benefits. And also it clearly states the most recent update in the revision history. So if the project received lots of merge requests and grew over time, but the threat model not, so that basically is a sign of eventually something's left over there. And developers hopefully love code and they know the application best, usually they should. There might be some more benefits, but what about the drawbacks of code? Having a threat model as code. It's code, someone has to write it, definitely. Some people might find code hard to read. Me being a developer, I'm not going along with that argument, but I totally understand that. That's not something everyone finds pretty easy to read, totally understandable. And it starts with the details. That's a major drawback when it comes to modeling. It starts with the details, not the abstractions. So it's not easy to spot the big picture just by looking at the details first. That's definitely a list of drawbacks. Might be some more, just some examples. So how now can threat modeling be part of DevSecOps environments and having something like threat models as code? The idea was to have some kind of simple solution that combines those major benefits, but have as few as necessary of the drawbacks. And that means, well, better don't let it be code in terms of real source code, but something that's processable like code and more easy to read and to write for a human. And the easiest markup language that a human hopefully can easily write and read would be YAML. Many times we're using that in DevOps environments, workflows and stuff like that. So it's already understood by all IDEs and it's pretty simple and easy to read and write and pretty simple and easy to consume from a program's point of view. And then the idea was to describe in that YAML file the classic elements of your threat model, your architecture, the data assets, your processing. Is it financial data, reporting data, health data, personal identifiable information, whatever kind of data assets you have. The technical components. So basically those boxes one would draw on a whiteboard or on a flip chart if it was a classic threat modeling session. So your technical components, your services, your processes, your data stores. And the communication links, so that the lines connecting all those elements, so where the data is actually flowing. And finally, the trust boundaries. So to have some kind of boxes separating one set of components against another set of components and separating that from other ones. So the classic trust boundaries like network trust boundary or cloud security groups or network isolation policies or stuff like that. Then the idea was to use some kind of open source tool to analyze that as a graph of connected components with data flowing between them, analyze that model file. Searched for that, but didn't find anything that I was saying that was matching these kinds of requirements for me. And so I created one that creates model graphs out of the model file. So we still need to have some visual representation that is allowing to spot as a human that we misplaced some component in the wrong box, in the wrong corner, or we draw a wrong connection between a few components, or we missed some other connections that should be there. So we still need that visual graph, the diagram, definitely, but we're not starting with the diagram. So they can be generated. The threats, the risks, that basically is the outcome of a threat analysis that needs to be created, definitely, and hardening recommendations, how to mitigate those kinds of risks and threats in the architecture. So giving potential development teams those kinds of tips and hints where to look for how to mitigate the identified risks. And that's more for the bigger corporations, also very important, all those kinds of documentation requirements and reports that need to be created, that can be created from the detailed model file, hopefully, as well. And that's what I created. It's basically an open source project, Agile. That's an Agile threat modeling toolkit, if you name it that way. It's living on GitHub and Docker Hub. It's MIT license, so a very permissive open source license. And it's exactly doing that. So you create a threat model as a YAML file, and then it generates all those nice outputs and does a rule-based risk analysis. And you can even add custom risks. That's also important because you should definitely from time to time conduct those workshops. They are not superfluous, no. They're definitely very important and very good, but you cannot do it on every sprint. So this can be seen as some baseline threat modeling with a rule-based detection, and from time to time in major releases, you can have those bigger workshops to actually get also to those threats that no tool will ever identify, like business threats, but they can be added to the model manually as well. Well, it's technology aware modeling. So you model with some kind of detail in terms of technology types being used or protocols being used, so that the risk rules, and there are over 40-ish in that, can analyze the graph very precisely, leading to less false positives. And of course, it has a plugin interface so that you can plug in your own custom risk rules to extend that. And a few more values are being calculated. What this means, RAA and DBP, just a few minutes later, going into that. Agile also has some kind of model macro concept. That means that you can automate certain changes to the model or certain enhancements or adjustments in a wizard-style question and answer, giving you some way to automatically enhance existing model files depending on some questions that you ask and answer them. So that can be used like adding a build pipeline to a threat model. That's one of the existing model macros that basically asks you questions about how your software gets built and deployed, and then it automatically extends the model to include these elements and these data flows. As said, Agile is released as open source software, MIT license, and runs totally offline, of course. So that's definitely something easy to use. Here you see it. It's a Docker container, everything included, and it's a command line interface. So it's basically just a simple CLI to work on that model file and generate the output. Or you can also start it as a REST server or web server with a REST API. So if you want to have it running remotely somewhere on your premise, then you can also run it as a server if you like. And the first steps when you're working with Agile is to, well, either take the filled example model to play with that, or just the minimal stub model, which is a very simple model containing just the minimum input that you can then use as the foundation for adding more data assets, technical assets, communication links, and trust boundaries. Here we see an example data asset modeled in YAML in the thread model file. So it's here some customer contracts, whatever it's taken from the example. It's that each data asset has an ID, an identifier assigned, and a little bit of description for the documentation. And the lower three lines, confidentiality, integrity, and availability, that's basically where you rate your data asset in terms of these protection goals. And then you model the technical assets, the components you would draw on a whiteboard. Here's some example, also from the example file, a web server with an ID, obviously to reference that later on, a selection of type, that's from classic threat modeling. Is it a process, a data store, or an external entity? A little bit of more questions to be answered, and also some information about the encryption of that thing, or also the CIA, confidentiality, integrity, and availability ratings, and a little bit more that you can supply as a little bit more detail. And most importantly, you reference on that data asset, on that technical asset, you reference what data assets are being processed or stored on that kind of thing. So if it's a data store, it would be more on the stored assets side, I would suppose, but also a web server processes sensitive data eventually, so that you can reference that way. And then the outgoing communication links, basically drawing the lines between the components. Here, under a technical asset, you're just referencing an ERP system for that example here, and you specify a protocol. Here, you've got a large list of protocols you can choose from, and that basically means Threagile is automatically, if it's an encrypted protocol, of course, taking this as an encrypted protocol, otherwise it's unencrypted. And also, you can supply what kind of authentication and authorization is being used if it's an authenticated and authorized checked communication link. It's a little bit of more things you can optionally answer. And also here again, most importantly, you reference the data assets that get sent and received via that communication link. And last but not least, the trust boundaries, those boxes that you basically use to group and isolate certain components from other parts of your architecture. There are different types of trust boundaries that you can choose from: network security group, network VLAN, or cloud security group things, or isolation policies in containerized environments and stuff like that. So here you give it just a name, and also you just reference the technical assets that are being placed in that kind of trust boundary. And you can also nest them to have some kind of nested trust boundaries, like a cloud network and certain cloud security groups in that. At the end, what's a Threagile run? It's just reading that YAML file, processing it, executing all the built-in risk rules, including the custom developed ones, if you have any, and create some nice output. Here, that's the example model coming from the Threagile Docker container. And here you see it's auto layout generating some kind of visual representation of your architecture. So the shapes and the colors, they resemble certain things, especially the lines and the border colors where sensitive data is flowing or stored, so that you can easily spot in the picture where the hot zones are that you need to protect more than other areas of your environment. And some PDF and Excel reports are generated. The PDF report with the risk result, the risk analysis result, is a little bit long. It's verbose because it has 3 redundant angles to view the same content. So first, it's a view of the risks by vulnerability category that have been identified. The other one is representing more or less the same data, but by technical assets, so it's a different kind of grouping. And the third one is for the data assets to present the risks associated to those data assets. Some kind of impact analysis, including manually added risks, if you added any of that. And you've got a before and after view. So you can also maintain the risk mitigation state inside Threagile in the YAML file. So each risk gets a unique identifier. that you can then use in the model file to assign a state of whether that risk has been accepted, if you want to just carry that, or if it's in progress of being resolved, or has already been mitigated, or something like that. So you can assign a state, and here you see the diagram then by identified risk criticality, and the bar chart then basically in terms of the colors gives you an impression of how many percentage of those identified risks are still unchecked. That's not good, obviously, here in the example model. Good, and then you get the impact analysis of the remaining risks. Those that you want to or need to keep because you cannot or do not want to mitigate them. So the remaining risks basically are those that need to be accepted by someone later on. If you're into the classic stride modeling of analyzing threats on an architecture, here you have a grouping of the same identified risks to their respective stride categories, and you can click on each of these titles to jump directly to that risk chapter. So the PDF is quite good to navigate. It's fully linked, and same is here for the assignment by functions. So what kind of group should usually take care of that mitigation step or mitigation steps? So is it either something to be addressed or checked with the business side, or on architecture level, development, or eventually also on the operations? Nice one, relative attacker attractiveness. This one is also generated. That's or calculated actually. That's a value, that's a number ranging from 0 to 100%. That's a pluggable algorithm inside Agile. And the default one is basically assessing each of the modeled components to see what kind of data that is stored or processed. It's more interesting for an attacker if it's stored data, of course, on or by that component, and how this data or these data assets are rated in terms of confidentiality, integrity, and availability. And the higher the rating and the more interesting data there is, the higher the number for that component. And then in a second run in the calculation, even those components sitting close to an interesting component in terms of having interesting data to be stolen eventually, but itself, the other one, the neighbor component, not having any interesting sensitive data, like just being a simple monitoring whatever that has some kind of connection to the interesting system, then even the by itself not being very interesting from an attacker's point of view monitoring thing gets a nice promotion in terms of this value, relative attacker attractiveness, because it sits quite close to a very interesting component and might be a pathway that an attacker can get a foothold into that target component actually. So that's like lateral movement in a backend system, something like that. So those close to interesting systems that are also, in terms of connections, that are also higher rated in that algorithm. So you see in bigger architecture, that's a very simple example here. You see, given that RAA value, where you should put usually your most direct prioritization on hardening those systems and eventually isolating them on. And also some other values calculated that basically resembles the blast impact of a risk if it actually manifests. So that means the data view here in the report lists the data assets that you have modeled, and they are all having some data loss probability or data breach probability assigned. That's actually a value that is taking into account of where those data asset is stored or processed, where in terms of on what components, and what are the associated risks of that component due to the threat model rules. And if such a component has a high risk of being attackable in one way, and this is not mitigated, then basically the risk of having a data breach with that data asset being part of that also is elevated. So here in that result, you see basically if you're very interested in keeping certain data assets secure, hopefully you should keep all of them secure, but some eventually more, then you see a listing of what risks you should check and mitigate first to reduce the data breach probability for that data asset. So that's basically the same view on the same data, but from a different angle. Here coming from the data assets point of view, what do you need to do to mitigate risks there? Of course, the risk mitigation recommendations are also in the report. So giving the developers or whoever consumes that, security analysts, information about what the impact of that risk would be, how it's detected, and what the false positives could be, so that you have got a very nice description of what you should check, of whether, if that's the case, then it might be a false positive. And also the mitigation steps, that's most importantly for the development teams or architecture, to have a clear listing of what should be done to reduce that risk from manifesting. And I'm referencing lots of very excellent OWASP stuff, like OWASP ASVS chapters and the brilliant cheat sheets. That's very excellent, so that developers have direct input that they can consume. And then the risk instances are listed where those risks are identified. You even see some rating depending on the sensitivity of the data that's sitting there, whether it's medium, elevated, or high severity, and the state. So here in this example, many of them are in unchecked state still, but some are in accepted or mitigated state. So this is also updated in the report once you fill the mitigation state into the model file. If you're into that, that's okay, the PDF, but more or less, when you're using it many times, then you get used to using that and knowing what's inside. Then you usually work with the Excel reports that you can filter and easily screen and glance over the identified risks and threats and get to the mitigation state as well. So same data, easier to consume. That's what I use many times, because making that part of DevOps or DevSecOps means to automate things. So also the results are presented as JSON that can be processed, obviously. We have a set of constantly growing risk rules. So it's currently 40-ish something. And here an example risk rule, by the way, Agile is written in Go, simple Go code here. So you see the text and you see that is being used for the documentation. And also you see the document generation. You see the rules basically looping and walking over that graph and checking certain aspects to create and identify these risks with as few false positives as possible. Editing support is also available. So if you fear editing a big YAML file, it's easy because IDEs have very nice navigation for that. And there's a schema available that you can import, YAML schema from Agile, that basically gives you linting here. You see on the left side a typo web server. So it says that's not in the enum of allowed technologies here. So that's a wrong value. And you can just begin typing, and then the auto completion box pops up, and it's basically quite easy to code that or to create that. Risk tracking state is also taken care of. So you have, as said, each risk has a unique identifier, a speaking one, untrusted deserialization at ERP system, or LDAP injection at something, asterisk. And so you can have in these groups, you can even use wildcards to assign a certain state to a group of risks. I would not recommend that, better being on the one-on-one level here. But if you want to group certain risks and give them all the same state at once, you can do this as well. And you can reference some external things like a justification text, a ticket ID, a link, whatever you want to put into the report. And a status, that's important, of either being unchecked, in discussion, accepted, in progress, mitigated, or false positive. What about bigger models? Yep, another example one, and that's just a very small compared to the biggest ones that I've seen, customer sites, but that's a different story here, and that's an example model again. So I even used one example file here that creates something that still fits on that slide. And even here, the auto layout is automatically creating that in a very nice way. So it's even some nice documentation built bottom up. A REST server is existing as said, so you can even have that running as a REST service instead of the command line interface if you want to do that. And we have model macros that can automate in an interactive wizard style certain things like adding build pipelines or adding a vault or identity provider or whatever to the model. If you're using GitHub, there's a, for CI/CD, there's an example online in the repo, which is a GitHub integration with a GitHub workflow. So here's an example. There's an official Agile action for GitHub that you can use. So every time a Agile model gets pushed, to the repo, then the Agile action is actually executing and running on that model. It generates the results and the reports, and you can even, if you want to do that, auto update the repository page if you want to do that. Or other way, anyway, process the results. Good. What are the hopefully the possible effects of that kind of open source tool to model threats and your architecture in an agile fashion? So it's basically that some corporations might eventually come up with custom coded risk rules that can analyze the model graph. So if you have custom policies you'd like to be checked and vetted against your architectures, your projects, that's a way of doing that, like certain components need to be in certain areas or something like that. And you can get a uniform documentation, hopefully, being built up of your landscape, bottom up. That means by the development teams, where in the IDE, basically they know the applications they're creating best. So it's where the truth lies. You can instantly regenerate all of that. So either if a data classification changes or you shift some component into the cloud, you can regenerate the result. Or you can do it corporate-wide. If you're in a regulated domain where you, for example, have a new policy that you need to implement in terms of security by some due date, then you can have a custom risk rule eventually for that. And you can then basically regenerate all the models for your projects, and then you would see which of these eventually catches some to-dos until that due date. As said, that's the thing I'm in, CI/CD pipelines, so to automate these things so that can easily be put into CI/CD pipelines to have some kind of trend analysis or some warnings when some rollout might happen with unchecked high risks still being there. So no one has checked these high risks. That's not good to go live then. So eventually this means threat modeling is part of DevSecOps. Hopefully that's the case. So security eventually can also be less bottleneck for threat model sign-offs. So focusing more on the business risks and those kinds of technical risks that no tool could ever identify, but having the baseline checks and risk analysis happening in an automated way. So that would be nice. Good. Well, what are the upcoming features? More documentation, samples, screencasts. There's a video already online. A little bit more should be coming. Web-based model editor, that would be cool. If you take a look in the code, you see that the REST API has even the foundation for that, even more than what's documented in the OpenAPI specification. So that's the foundation of something that can evolve easily into some web-based model editor. Also linking, that's a feature that I've been seeing that users of Agile are demanding that in a very, very high amount. So to have some kind of way to split models into submodels and link or include them. So the idea is here to have in the next version then layered graphs. So basically you've got a visual representation where the surrounding context systems out of scope are just black boxes with the connections going in. And if that's another model that's existing somewhere else and it's properly linked, then you can have a second layer being rendered where you drill down into these systems as well and see their details. So that would be nice. Cloud crawlers, also some nice idea to use them as a model macro to get the input from your cloud environment, and then you can select and choose what components you would like to pull into your model. GitLab integration, you've seen already GitHub has been finalized. GitLab, well, I've seen a ticket online that they're considering to think of Threagile being eventually part of the CI/CD thing there as well in a similar way. That would be nice. And eventually you also could use some input from CloudFormation or Terraform to seed the initial model. Good. Also bug tracker integration. That's very important. Jira, Defect Dojo, and anything else would be nice to have some kind of consistent way of handling the output. The tasks for development teams or whoever of the team should check those output. And eventually integration with Draw.io. I would say eventually as a possibly as an initial sketch to create that thing and seed it into the model file. That needs to be worked on. We will see how this will be a thing. Good. Also, your IDs and feature requests are very welcome. So feel free to file them on the GitHub repo. Here you've got the website on Agile.io, or you can have the playground on Run Agile.io, where you can basically see the Docker container that you can just download running there as well. So you can play with that. We do have a chat, GitHub community chat, and the source code, as said, sitting on GitHub, MIT license, very permissive open source license, and the container ready to run also sits on Docker Hub. Nice. So from my side, thank you very much. Thank you for your time. And well, then time for some good and nice Q&A on the Slack channel. See you there.